Let us try another example to determine the coordinate of the centroid of an area. We are given a function y equals to 5x minus x squared, and the area of interest is between the curve and the x-axis. The boundary conditions is not given, but you know that it will be governed by the intersections of the functions with the x-axis. Determine the positions of the intersections with the x-axis. Write down the functions. Taking the y equals to 0. Factorize the functions here. You know that x will be equals to 0 and equals to 5. If you sketch the functions, it shall look something like this. The area between the curve and the x-axis will be here. With that, you know the boundary conditions will be from 0 to 5, and you expect the centroid is going to be somewhere here. Use the formulas to find the centroid x prime. Specify the boundary conditions from 0 to 5. Integrations of xy dx divided by y dx. Substitute y into the equations, you get this. Rewrite the functions. Integrate the functions. Solve the functions by substituting the upper and the lower boundaries, and your x prime will be 2.5. For the centroid y prime, this is the formula. You have a y square here and y here to be integrated to the dx. Substitute y functions into the equations. You will get this. Expand the equations of the square, you get this. Integrate them separately and specify the boundary conditions. Substitute the boundary conditions into the equations to solve it, and you will get the centroid as 2.5. Based on the calculation here, you know that the coordinates of the centroid, it will be 2.5, 2.5.